Okay, let's look at section 3.3. This section talks about the proof by contrapositive, right? Remember that if you have implication, for example, P implies Q, then it's contrapositive. It's contrapositive is logically equivalent. So instead of proving P implies Q, we can actually prove not Q implies not P, right? So let's do that. So what we need to do is, as usual, we want to prove that for all x in some set S, P of x implies Q of x, right? So instead of assuming that the P of x is true, we're going to assume that not Q of x is true, right? Then try to show that not P of x is true, right? So this comes in handy when it comes to having a fairly complicated hypothesis and a really simple conclusion, right? Let's see, so if you want to prove this statement, so 3x minus 5, or actually, I forgot to put for all x that are integers. So x is an integer, all right? So this is the statement we need to prove. So let's write the proof by contrapositive. So proof by contrapositive. All right. So let's assume that not Q is true. So F is odd, not F is odd, so F is even. So we assume that not Q is X is even, right? Once you know that X is even, then we know by definition, all right, there exists some integer k such that x is equal to 2 times k, right? Then we can rewrite 3x minus 5, right? So this is going to be, right, 3 times 2k minus 5, which is 6k minus 5, right? So what we can do is we can write it as, all right, so this is the same thing as 6k minus 6 plus 1, right? Then we can pull out 2 from the first two terms, so 2, right? Then you have a 3k, pull out 2 from negative 6, so negative 3, right? Then you have a plus 1 at the end. All right, so you can see that 3x minus 5 can be written as 2 times some integer, namely 3k minus 3 plus 1. All right, so there exists some integer L. Actually, L has this form, 3k minus 3, which is still an integer, such that 3x minus 5 is equal to 2 times L plus 1, which indicates that this is an odd integer. So this implies that, therefore, 3x minus 5 is odd, right? Which is then not p of x is true part, right? So this would be the end of the proof. So we actually show that assuming that the not q is true, then we could show that the not p is true, right? That's it. So this is called a proof by contrapositive, right? I hope that this was clear.